Hello student, today we are going to learn torsion equation for circular shaft. The name of the chapter is torsion. Under strength of material, let us consider a circular shaft rigidly fixed at one end. The radius of the shaft is R and length of the shaft is L. Okay. The shaft is subjected to a pure torsion due to the application of torque T at the phi end. This is the front view, this is the side view of the solid circular shaft. This end is fixed and this end is phi. A line AB on the shaft surface will be distorted to AB dash after the application of the torque T. In front view, B move to B dash on the surface. The angle of distortion phi. Phi is the angle of distortion. In side view, B move to B dash on the surface, twisting its cross section by theta. Theta is the angle of twist in radian. B dash equal to theta. Okay. Here Fs is the intensity of shear stress induced at the surface of a shaft of radius r. At radius r, at the surface, the shear stress induced Fs. Theta equal to angle of twist. Theta is the angle of twist in radian. L equal to length of the shaft. G equal to modulus of rigidity. Now, shear strain phi equal to, phi means angle of distortion, equal to B dash by L. Actually, shear strain equal to tan phi, as phi is very small, so tan phi equal to phi equal to B dash by L, AB equal to L. In side view, B dash equal to r theta. So phi equal to b dash by L equal to r theta by L. Again, from Hooke's law, we know shear stress by shear strength equal to G. G equal to modulus of rigidity. So shear stress Fs, shear strength equal to r theta by L equal to G. So Fs by R equal to G theta by L. This is marked as equation 1. Okay. Here Fs by R equal to G theta by L. Fs shear stress induced at the surface. R is the radius of the solid circular shaft equal to d theta G theta by L. Since for a particular shaft G theta by L is constant, so we can say Fs proportional to R. Shear stress at any point on the cross section is directly proportional to the distance of the point from the center of the shaft. So Fs proportional to R. Fs1 equal to R1 equal to Fs2 by R2, so and equal to constant. Here R1 radius from the center, at R1 shear stress Fs1. Here R2 radius from the center, at R2 shear stress induced shear stress Fs2. Okay. Now this is the cross section of the solid circular shaft. Here surface radius, outer radius capital R. Considering an elementary ring of thickness dr, at a distance r, from the center O, and shear stress at this radius BQ. Shear stress at this radius Q. Okay. We know Fs1 by R1 equal to Fs2 by R2, so on. Ratio of shear stress and radius from the center is constant, so Q by R, Q is the shear stress at radius R, Q by R equal to Fs by capital R. So Q shear stress induced at radius R, Q equal to Fs by R into small r. Now area of the elementary ring, this is 2 pi r and thickness is dr. So 2 pi r into dr. Now we know stress equal to force by area. So turning force equal to stress area, as stress equal to force by area. So stress at this radius small r, Q equal to Fs by R, capital R into small r, Fs by capital R into small r, into area equal to 2 pi r into dr, equal to Fs by capital R into 2 pi r into r, that means 2 pi r square into dr. Okay. Now turning moment means turning force into distance. Turning moment of this elementary ring, equal to turning force into distance from center, equal to r. So turning force equal to Fs by r into 2 pi r square into r, that means 2 pi rq into dr. Okay. Now total torque transmitted by the shaft, capital T, equal to torque of the elementary ring, equal to Fs by capital R into 2 pi rq into dr. Now we integrate from 0 to r, from center to surface. Radius at 0, center equal to 0, radius at surface equal to r. So we integrate 0 to r, integrating r q, we get Fs, this is the constant term, Fs by r into 2 pi, and this is capital R to the power 4 by 4. Okay. Now we know polar moment of inertia Ip equal to Ip for solid circular shaft, pi by 32 capital D to the power 4 diameter of the solid shaft D, equal to pi by 32, D equal to 2r to the power 4, equal to pi by 32 into 2 means 2 to the power 4 means 16, r to the power 4 equal to pi by 2 r to the power 4. Okay. Now this 2 and this 4, this is the 2. Now we put the value this is IP, this is the IP. T equal to Fs by R into IP, polar moment of inertia. So we can say T by IP equal to Fs by R. This is the equation. This is the equation 2. Okay. Now from equation 1, Fs by R equal to g theta by L. This is equation 1. And from equation 2, T by IP equal to Fs by R. This is equation 2. From equation 1 and 2, we get T by IP equal to Fs by R equal to g theta by L. Okay, it is clear, my student. Thank you.